Okay, thank you very much. So, yeah. Now we move it to our next session, which explore fascinating the forward-looking area of artificial intelligence. It's my pleasure to invite Dr. Lahiru Ariyasinghe to the stage. Dr. Ariyasinghe will be speaking on the topic Small Language Model SLM, the concept compact future of AI. Dr. Lahiru Ariyasinghe, please come to the stage. You are good at talking.
All right, thank you. So we had two sessions, one related to primarily prompt engineering, and the other one related to AI, privacy and stuff, which is really good because these two talks we had kind of giving some foundation for what I'm going to talk about. SLMs, small language models. So I hope everybody here, as described in other talks, using ChatGPT-like tools to generate emails, creating proposals in your companies, maybe using ChatGPT, or even sometimes doing ideation, brainstorming, and even using ChatGPT as kind of the replacement for Google search sometimes, right? Because now OpenAI is allowing people to straight away jump into ChatGPT without logging in. So people are using ChatGPT basically instead of Google search. Sometimes I have seen. And even sometimes, now we saw in the previous talks as well, we can even create lightweight products, PPTs and everything. So it's fascinating to see how AI is going to take over our creativity and our thought process and maybe intellectual abilities. And that's going to be a separate topic on ethical aspect of AI. But what I want to talk about is all the things that you do with ChatGPT, all the things that you do, all this email generation, all these things, there is something called language models in the back, in behind, right? So we heard about GPT-4, DeepSeek, Gemini, Claude models, all these things. So we have two categories mainly. One is large models, large language models, LLMs, which is the common term. And we also have small language models, SLMs. So I hope in the crowd here, there may be our team or our people maybe who are more familiar with SLMs or who are a bit new to SLMs. So what I will do is, I will not go too much into technical details, but I will try to have the balance. So you can really understand what is a SLM, what's the difference between a SLM and LLM, and why we really need to think about it. And companies like Microsoft, Google, Meta, why they are pushing so hard on SLMs. Okay, and all right, think of this example. I have my house and I want to go to the supermarket. Only 2 kilometers I want to go, right? I have two cars. One is my racing car and the other is my, let's say, my Alto, right? So I can go to the supermarket in my race car, no problem. But in that case, I may be wasting some of the resources, right? I may be wasting fuel, and I really don't need that supercar to go to the supermarket and buy maybe 10,000 worths of good, right? I can do it using my Alto as well, no problem. Going from point A to point B, a set distance, and it's get the job done. So I really don't want to use my supercar, right? Alto is more than enough for my requirement. So that is kind of the theme I want to pitch in here today, right? There are a lot of use cases in the enterprise ecosystem. You really don't need the scalability or the capability of LLMs, right? I mean, you can use them, that's fine. They will give the accurate answer, but again, you are wasting money, you are wasting computation, and also you are indirectly impacting on carbon footprint, right? But if you have a SLM which can get the job done, why you really want to worry about LLMs, right? So that's kind of a theme I want to talk about. And my objective here is today, you will learn at least something on SLMs and maybe try to find out what are the use cases that you can actually use SLMs instead of LLMs and make the most out of it. Okay, so nowadays everybody is talking about generative AI and also agentic AI, right? So people who are from AI, who are not from AI, everybody is talking about AI, generative AI, agentic AI, organizations are having AI roadmaps, budgets are there, all those things are there. But actually, generative AI especially, although it is something new for most of us, but if you are a AI researcher or a professor who is closely watching how the field evolved, it's not going to surprise you too much, right? So the entire buzz started with ChatGPT, right? Fair enough. So OpenAI introduced ChatGPT in late 2022, right? So this introduction gave rise to consumer AI, right? Consumer AI means AI and applications which are directly impacting to consumers, individuals, not businesses, not enterprises, not industry, right? So, but didn't we have consumer AI before ChatGPT? Google Translate, again, a Gen AI tool, right? AI tool used for consumer AI, right? Then all these wearable devices, smartwatches, right? Smart home devices, all those things were there actually. But OpenAI opening this, introducing ChatGPT and being able to talk to this thing, right? That's the kind of the difference that we feel. You don't feel that in Google Translate, right? You don't feel that in maybe lightly you felt with Siri, Cortana, all these things. So the magic here is being able to talk to it in a more human manner, right? You're just talking it, right? Compared to searching it in Google, right? That's kind of the tipping point, right? Then from that point onwards, a lot of companies started working on consumer AI and a lot of investment is coming on. So everybody is now excited with Gen AI, agentic AI, all these things are there, right? Okay, so then what is this generative AI then? So I think Sanjit had some explanation in his slide, right? So kind of the same thing. Gen AI is actually a part of AI, part of deep learning actually, right? Which can create new content, right? So when you say content, it can be audio, video, and synthetic data, and our good old text, right? So the Google actually published this paper in 2017, right? Attention is all you need. This is the paper which gave the boom, which was the catalyst for generative AI, right? This is where initially the transform architecture was introduced, right? So I will not go into too much. Transform architecture is a kind of a deep learning architecture, which is the, the main brain behind all these language models, all large multimodals, right? So with the Google's paper, it was the initial catalyst, and you can see it's in 2017, right? But we all started talking about Gen AI in 2023 or even late 2022, right? So that is with the introduction of ChatGPT, right? So in Gen AI, as we now know, there are different verticals. You can create text using Gen AI, our common tools, ChatGPT, Gemini, Claude, DeepSeek, all can be there. And then generating image using Gen AI. So Midjourney, Adobe Firefly, Crayon, these tools. And generating video using Gen AI. So again, OpenAI has a solution, Sora. Runaway is a good platform, and InVideo AI. So these are different modalities of Gen AI, right? So the last one, audio, creating audio. So Landar and 11 Labs, two platforms, two companies rising in the sector of generating audio using Gen AI. So we have these different modalities, and this particular branch of AI can create new content. So it feels like magic most of the time, but if you are kind of comfortable, or if you have studied into the transform architecture, it's not going to be something very fancy for you, right? So in this talk, we'll try to dive into little bit into how LLM works. I will not jump too much into theoretical transform architecture level, but with lame terms, let's try to understand how an LLM actually giving these outputs, right? Now in Sanjit's talk, we saw it is doing a lot of interesting things. So how it can do this? So before jumping into how, some examples. These are very common now these days. Actually, I took it from one of my talks last year. At that time, they were very interesting. So creating images from Gen AI, and the middle one is actually a video. It's a small video which I created using Gen AI, like that. Okay, so before understanding how LLM works, let's try to understand this terminology first. What is the flow of a typical Gen AI application, right? So very easy. We have a user, right? And we have an application, something like ChatGPT. And the back end of ChatGPT, there is something called foundation model. That is your GPT, GPT-4, GPT-4o, your foundation models, right? So the user can interact with the foundation model using prompts, right? You can give inputs, we call them prompts. Application will interact with the foundation model, and it will give you an output. We call it a completion. So it's always a prompt and a completion pair. So that's for generic users. If you are a developer, you can interact with the model using an API endpoint, REST API endpoint, right? So that's the same case again, using whatever your preferred language, Python, JS, whatever. You interact with the REST endpoint, you give a prompt, you get a completion out. It's always working as prompt and completion pair, right? So the foundation model, it can be, if it is ChatGPT, it can be GPT-4, 4o, 4.5, or if it is Claude, it can be Haiku, Sonnet, different models are there. And this concept of tokens, right? This is a screenshot I got from OpenAI token calculator. So the input that you are giving to a foundation model or an application, right, which is backed by a foundation model, we call it a prompt, right? This prompt is considered in terms of tokens, right? So for the model, it looks in terms of tokens. Now, when you take that question or the prompt, right, explain to a 10-year-old what Gen AI is, generative AI is, right? So there are 12 tokens. So basically, the foundation model is going to consume your prompt in terms of tokens, right? You can say like words in your sentence, roughly, but it's not always, right? You can see the term generative is taken as 2 tokens, right? But you can closely say it is something similar to maybe the Java's string tokenizer class, right? So it's constituted in tokens. And if you are going to use language models, cloud native language models like GPT, you are paying in terms of tokens, right? And the concept of context window, right? This is another screenshot I got from OpenAI's latest GPT-4o model. The one which I have a red circle here, context window is 128,000, right? That means your foundation model, let's say, let's go for a simple number. If the context window is 1,000 and your prompt is having 500 tokens, there are 500 left for the completion. So the total of prompt plus completion tokens is known as the context window, right? Now this 4o model is supporting 128,000 tokens. Right? So when we were starting Gen AI track at ADL, we had GPT 3.5 Turbo, which had only 4,096 tokens. Right? 2 years passed. Now there are models which can support 128,000. You can basically input a document if you want. Right? In 2 years back, we only could input maximum 4,096. So the prompt should be less than that, right? So for this about 2 years, you can see how the models are improving. So the techniques that we used 2 years back, we don't really need them now because there are larger context windows with the models, right? So the concept of context window, it's always the total number of tokens it can support, prompt plus completions. So if you are a developer and using a foundation model like GPT-4o, you should be aware with this number because if your prompt is going to be too large, there is no room for your completion or the answer from the foundation model. So it will cut off from there. Obviously, you will get that error, API endpoint error. All right. Now the discussion of today's main course, LLMs. So what is a LLM? Basically. So I coined the term foundation model. So LLMs are a class of foundation models. Basically, they are trained on very large data sets. Assume the entire Wikipedia. They are trained on very large data sets and they have foundational capabilities to drive different use cases. Foundational capabilities means understanding natural language, generating natural language, continuing a dialogue. Those are foundation capabilities, foundational language capabilities. So these foundation models, they have these capabilities so that we can use them to drive different applications in different use cases in different contexts, right? This image, actually I generated using GPT-4o. I asked it to generate an image to showcase the concept of large models. It's not that very good, but you see, that's again relating to the previous talks. Everything is now getting automated. So the basic understanding of a LLM now we have is a foundation model trained on a large data set which has foundational capabilities. And what is a foundation model then? Basically, it is a neural network, a deep neural network, which is again trained on a massive data set like the entire Wikipedia, and it has these foundational capabilities I talked about. Understanding natural language, generating natural language, and so on, right? So the important thing is these foundation models are trained on unlabeled data, right? Unlabeled generalized data. So if you take the entire Wikipedia, that's a generalized data set, and you don't really need to label them, right? So if any of you are from data science or ML, you know supervised learning. We need to label data sets. So I will explain the reason later. But with these foundation model, when you are initially training them, when OpenAI was training GPT, they don't really need to label data. That's because of an inherent capability of the transformer architecture in foundation models. We'll see that later. But the point here is, when you say foundation model, you are referring to neural networks, large, dense neural networks, simply. And the difference here is, now, we know we have models for doing specific tasks, right? Let's say sentiment analysis from customer reviews, or fraud detection, or image classification, right? So when when we were in 2019, computer vision people were training CNNs, right, for classifying maybe vehicles, maybe different scenarios in medical imaging, all these things. So those models are trained on that specific thing. They can only do sentiment classification. They can only do image classification. But foundation models are different. Foundation models, they are based on foundational capabilities. They have the foundation, primarily natural language understanding and generation, so that they can be used in multiple use cases. They can be used in sentiment analysis, sentiment classification. They can be used in image classification. They can be used in fraud detection. In all the use cases, you don't really need to have separate models. That is the beauty of this foundation models concept, which actually came to the scene with the boom of Gen AI, right? And these foundation models are actually going to change what data scientists have been doing for the last, let's say, 10 years, right? So the data scientist job is very, very interesting, because we are scientists and we are training models. We say we train the model, those things, right? But when you go into the future, in the future, you won't be able to say that much, right? Because there are foundation models, you don't need to do that training from the scratch. You can use a foundation model with the basic functionality, and you can use it in your use case accordingly with prompt engineering, right? So that's the idea and the beauty of foundation models. Okay, so LLMs, what are the leading LLMs? This is kind of all we know, but just for the completion, we have GPT models from OpenAI. The latest one is 4.5, which they released around February. And GPT-4 is there. And 4.0, maybe you have heard about the term LMM, not LLM, right? LLM. LMM means large multimodal model. The difference is, LLM like GPT-4 can only support text. LMMs can support the other modalities. It can work with audio, it can work with images, it can work with video. Now GPT-4o is a LMM. GPT-4 is a LLM, right? So whatever, so OpenAI has it all. And we have Gemini from Google, which we all know. So Meta released a family of language models. Llama, they have my favorite small language models as well. And Claude. Claude is another very interesting company. They released the same model with the name Claude Sonnet, Haiku. So if you have dev people here, software engineers, if you really want to generate code, Claude's Haiku model is a very good one compared to GPT, right? So it's, in terms of benchmarking, Claude Haiku model known to be really good compared to other GPT and maybe Gemini in terms of code generation, right? Something to check out. So likewise, we have these leading LLMs from leading players, right? Okay. And some information about these models. So when we talk about these models, maybe all of you have heard the term parameters. Everybody is saying, okay, this model is having this number of parameters, 10 billion, 100 billion, like that. So the parameters means, as I told you, all these large language models or large multimodals are neural networks. So in neural networks, we have those circles neurons. We call them neurons or parameters, weightages, whatever. But the common term is parameters. So when we talk about LLMs, we say, okay, GPT-3 has 175 billion parameters. Huge network, right? Now, GPT-4 is rumored to have beyond 1 trillion parameters, right? And remember, when the network is getting larger and dense, you need infra to support. So how you can understand how much money and how much infra is expanding, right? And Gemini, all the same, around 1.56 trillion. And all these GPT and Gemini models are proprietary, so they don't really release the value exactly. But Llama models are open. So Llama's, from Meta, Llama's latest one is around, not exactly for 405 billion parameters, right? So these are the parameters I mentioned. If you try to visualize a neural network, in a neural network, there is an input layer, there is an output layer, there are intermediate layers, and there are neurons which are connecting with each other, right? We don't need to go too much on neural networks, but that's the basic idea. So the parameters we are talking here is that, right? How many neurons are there in this particular neural network, right? And as a comparison, human brain is having only 86 neurons, 86 billion neurons, approximately. But GPT, as a neural network, having around 1 trillion, more than 1 trillion parameters, right? So I'm not trying to compare the human brain and an artificial neural network. But the point is, you can understand how quickly these models are expanding, how quickly the companies are trying to push the architectures, and how much they are investing on infrastructure to support this kind of large neural nets. But the beauty of the human brain is still these models cannot mimic that. That is what AI researchers are struggling forever. I mean, we are hitting with the number of parameters beyond the brain, but we can't match the functionality. Will we be able to? That is something we'll have to see in future if the field is going to go towards AGI, artificial general AI. Okay. Right now, the important part, how a LLM is going to work. So in these slides, I will not go too much into the transform architecture. If you have here any colleagues, friends who are from data science, bear with me. Let's talk about the transform architecture separately. To have a balance, I will try to explain how a LLM is working in a more high-level way, right? Now all of you saw, these LLMs can generate text, right? You give an prompt, it can give a completion. If you look under the hood, fundamentally, this LLM is doing a classification job, right? It is trying to predict in a given sequence of words or a sentence or a phrase, what is the next word? What is the next token? That is what, from the underlying transform architecture, or the LLM is trying to do, right? You give a prompt, it is trying to predict what is the next word. So I can give the word, the cat likes to sleep in the, it is selecting box, right? That's the basic thing. It's trying to predict what is or what are the next possible, highly probable tokens and selecting from it. So if you look into the fundamental machine learning, that's a classification problem, fundamentally, right? So think about a sentence like this. The cat likes to sleep in the box, right? Now then you will think, like, when I say it's a classification job, how this model can predict all these sentences very accurately. That is because of massive training data, right? Just imagine you have access to the entire Wikipedia. There are thousands and millions of sentences and phrases. So if you can train a neural network using that particular data set, how much different combinations will be there? That is why we say these are large models, large neural networks, right? Trained on very large data sets. So you actually get this one sentence, the cat likes to sleep in the box, right? You can have so many training examples. You start with the, and you are training the neural network to predict the word cat. You start with the cat likes, you are training the model to predict the word likes. And the list goes on. Even using a single phrase like that, you can create multiple instances. And you do the same for larger sequences. Also for code. You can do the same for code. That is why these models can do coding for you. That is why they can generate code. They were trained on large coding datasets, right? So that is what is happening under the hood. Now, when you start actually understanding what is happening, you will feel like it's not a big deal, no? Right? And the last part, natural language generation, right? So then assume you train your neural network with a large dataset like that. Now your model can predict the next word in a given sequence of word with a higher probability. Now model is really good at predicting it. Now, when you input a sentence like that, a trained language model it's trying to predict the next word. Generate. Again put it, a trained language model can generate, it's predicting the next word. Coherent. Likewise, the sequence is going. That is what is basically done with the transformer architecture. I know I'm kind of overlaying a lot of too much technical. That's why I told anybody here, bear with me. This is the kind of the high-level explanation. I really don't want to go into the theoretical stuff, right? So this is how basically LLMs, large language models, are trained and how they are able to predict and generate, right? So the other important thing is, this LLM, they don't need to always pick the word with the highest probability, right? Now in this example, a trained language model can be the word speak, or it can be generate, it can be politics, work, whatever. Or it's speaking generate, right? So the other word, coherent. So instead of coherent, it can be text, right? So likewise, it doesn't need to be the word with the highest probability. You can have a subset, right? You can have a subset and you can do a sampling. That is why when you input the same thing next time, LLMs are not giving the same thing again, right? You all have noticed that, right? If you ask the same question again and again from LLMs, it is not going to generate the same thing. It's going to change. That is because the model will sample from a list of probable tokens, probable words, right? And if you are someone working with Gen AI, I hope you know the temperature parameter in LLMs, right? That is what, using the temperature, that is where we control this, right? We set the temperature to 0 when we integrate with the LLM, then we try the LLM to be more deterministic. If you set it more towards a higher value, it's going to be more creative and selecting from that list in more higher random manner, right? Okay, so that is kind of the high level of how LLMs work. So the same concept, now this is for text generation, language models, but same thing for image and video as well, right? All right, so we understood Gen AI, what are LLMs, how LLMs are working, and the benefits of LLMs, I don't need to mention, we all know. They are very efficient in answering your questions. Scalability is there. Now assume like also obviously with infrastructure support, but models like GPT-4o or 4 is supporting billions of queries. So they are very scalable. The neural nets are very scalable. And the performance, right? They give you very accurate, most of the time accurate, engaging, good enough answers, higher in performance and accuracy. Also, multi-language support is there with large language models, not only English, all the other languages. User experience is very much improved compared to very early days. We used to have chatbots with basics of NLP. Compared to that, now LLMs are very advanced and there's a very high end-use experience. Users' quality of experience is very high these days. Okay, those are the plus points. Then what are the negatives? Everybody knows about the plus points. What are the limitations of LLMs? First thing, data privacy and governance. So my colleague before talked about the privacy aspect of AI. So LLMs, we have this huge challenge, right? I'll give you a quick example now. Okay, think that you are going to develop a healthcare chatbot using GPT-4o, right? So to develop that chatbot, if you have developed one, you know, you will have to interact with the LLM in the back end. You will have to send the queries the users are typing into the model and get the answers back. Now the GPT models, let's say most of them, I don't want to name a brand name, but you all know, right? All these cloud services, they host these models in most of the Western economies, Western countries. It can be US, it can be in the Europe, right? Hardly in Asia, at least still. My point is, they are not under your control. The models are not under your control. So you are sending data to the model side, and you don't know what the hell they are doing with the inputs. And if it is an industry like healthcare, fintech, telco, where data privacy is very important, it's going to be a problem, right? We don't know what OpenAI is doing with the prompts that we are sending to the GPT-4 model. Okay, they can say in the, user agreement, they are not using, that's fine. How many incidents we had with Facebook with plain text passwords, right? You just go and Google, right? You can't always guarantee. And the other part is, this is something with compliance, right? So if you are a healthcare provider, if you are a fintech, it's not you are okay with this, but as a provider, you should be compliance with privacy. So with LLMs, especially cloud-native LLMs, you have this issue. Now, even we also always face this problem. When there is a project is going to happen, okay, the client comes and all good, and they say, oh, no, we don't like GPT, we don't know to send data there, right? They say everything is down. Then we are looking for an open source option, right? So actually, that is where SLMs are shine. SLMs can shine. Hallucinations, the other thing, hallucinations. I think some of the previous speakers talked about hallucination. Hallucination is very simply, hallucination is a non-contextual output given by an AI model, right? Simply saying, you prompt something to a LLM, LLM will give an answer for the sake of giving an answer. It may not be accurate, it may not be related to the context. We call them hallucinations, right? Now you will understand why this is happening. If you can remember the previous diagram, always the LLM is trying to predict the next word in a sequence of words. So it is obligated to give an output. But if the sampling approach or the probability values are going wrong, whatever the word it's outputting may not be in the context, right? That's we call hallucinations. But remember, we really don't like hallucinations if you are working on projects where you need deterministic answers from LLMs, right? So I hate hallucinations. All the time hallucinations are there when we were using 3.5 turbo. All days, like 2 years old, right? That is why they had 3.5 turbo in stock model. 4.0 is much better. These days 4.0 is much better. But remember, hallucinations is a problem for us who are looking for specific outputs, deterministic outputs from LLMs. Keep in mind, for people who are creating things, creative writers, hallucinations is a feature, right? So from the research community, we really don't want to start removing. There may be an architecture which can reduce hallucinations to 0. But still keep in mind, hallucinations is a feature, not a bug. It's going to be a bug based on the context. If I'm looking for specific answers, okay, hallucinations is going to be a bug. But if I'm writing a crime novel, whatever, thrilling novel, hallucinations is going to be a feature for me, right? But again, whatever the context, hallucinations can be problematic, especially with deterministic applications. Higher infrastructure footprint, as I talked about these large neural networks, they need very expensive and very much capable infrastructure to run, right? Now, I just checked in the morning, in order to run Meta's open source LLM, which is having around 400 billion parameters, we need a AWS VM, which is going to cost you around $2 per hour, right? So I was looking to support 5 TPS, 5 transactions per second, right? So you can imagine if I run that LLM in my own AWS VM for 24/7, how much cost? And with GPT, we are talking about trillions of parameters, right? So it's a huge infrastructure cost. So that is why big tech companies are providing infra for this, right? Our tier 2, tier 3 solutioning companies, we don't need to worry about that. Big tech companies are providing money actually for this huge infrastructure cost. We just go there, get the LLMs, and develop whatever the application we want, right? And with this infrastructure, another thing comes, higher carbon footprint, right? Sustainable AI, that's a different topic. We need to discuss separately. But when Microsoft was training GPT-3, likely they have evaporated around 700,000 clean fresh water for cooling, right? So then you can understand, we all talk about the fanciness and the use cases of LLMs, they can do this and this and this, but there is a huge growing carbon footprint in behind, right? That is something to think about. So these are the two verticals. There are a list of benefits, but there are certain critical limitations are there. That is where we come with SLMs, small language models, right? So SLMs are basically, simply you can say, they are smaller counterparts of LLMs, smaller siblings of LLMs, right? Small networks. LLMs with trillion parameters, SLMs normally around 1 billion to 15. There is no exactly cutoff point in R&D. Still at research literature we haven't seen. But you can basically say something in between 1B to 15B, 10B-ish, you can take it as SLM. Or sometimes very small models in millions level, right? So what is the advantage there? Now the network is smaller, right? Network is smaller. Now you will think, okay, then the capability is going to be reduced. It's true, but there is a catch. If you focus, if you properly give the instructions for a SLM, it can do a far better job in a downstream focus use case, in a specific use case. For LLMs, you use LLMs for generating not images, but generating text in a different area, translating different languages, calculations, All these different use cases. There's a wide variety. SLMs, you can't do that, but you can use SLMs very smartly and accurately in focus use cases. Let's say I want to categorize the sentiment of my customers using customer feedbacks. Very specific downstream use case. Nothing else. SLM is the ideal option for that compared to LLM. LLM will get the job done, but you are paying too much money for tokens. You are indirectly contributing to the carbon footprint, and fine-tuning LLMs are harder. All these challenges are there. With SLM, you can get the job done very easily. I will show a couple of demos, because I have seen when I was talking to my colleagues, they think, okay, SLMs, can they do it? Can they puluang weida? Not sure na. That thing is there, right? Because everybody is thinking LLM is the thing. But what I want to highlight is, no, there are use cases, SLMs can be superior. First thing, SLMs can run in commodity hardware. Now I told you to run Meta's open source LLM, we need a VM at least $2 worth per hour. SLMs you can run without GPUs, even in your normal laptop with Olama. If you have tried it, you know, right? They can run on low-grade VMs or on-prem VMs, on-prem with very low spec. You can run them in your own VPC. You don't need to worry about the data privacy and governance, because you have the model where the data is. You are not sending data towards the model. You are bringing the model where the data is, right? So the privacy and governance compliances you can highly achieve here. So it can run on edge devices. It can run on your mobile phone. It can run on your router, right? A lot of use cases are there, edge use cases with SLMs, because smaller networks, they require very small infrastructure footprint. So as I told you, they perform very well in downstream focus use cases. So when we say downstream focus, there's nothing big. You just need to use SLMs in specific tasks, right? Don't try to get a SLM and do all your things. The LLM is there for that, right? SLMs are better and they can perform well if you focus them well. So easy to customize. So if anybody here who has fine-tuned SLM or LLM, they know it's relatively easy, very quick. We can run less number of epochs when we are fine-tuning a model. It's relatively easy for us. The dev team likes, they love SLM because relatively easily we can fine-tune compared to LLM. And we are, even at least indirectly, if we can encourage our ecosystem to start using SLMs more and more, right? We are contributing to reduce this carbon footprint and contributing to sustainable Gen AI. Okay, what are the popular SLMs then? So Microsoft, as always, they want to be in the forefront. They have their own open source SLM family, Pi. Pi used to had 1, 2, 3, 3.1. Now the latest one is 4, Pi 4. So I have listed Pi 4 is having different versions. The best one is 14 billion, relatively small network. 3.8 billion smaller models are there. And remember, SLMs now can support multimodal. They support image inputs and audio inputs. The characteristics that we have in LLMs, they are slowly coming to the SLM world. Right? So the Microsoft released the Pi 4 5.6 billion multimodal version. It can support both text and image and audio. Then again, Gemma from Google. All the big players are having their own fair share in the SLM game. Right? Gemma is from Google. Again, open source. You can open weights are there. You can easily download from Hugging Face and use. The latest one is Gemma 3. They have 3 versions. They have a very small model, 1 billion. Hopefully can run in your laptop as well. Then 4 billion and 12 billion models. And again, Meta. They are also there in the game. Meta is having Llama small models, Llama SLMs, right? 3.1 billion 8B. And they have a multimodal as well. The 11B version is a multimodal. And Quen is from Alibaba Group, right? Again, a very, very interesting family of SLMs. They have, again, a set of different versions, 1.8, 7B, 14B, likewise, right? And again, as always, OpenAI, they want to have their share as well. OpenAI is also having SLMs, but they are cloud native, right? They are not open, they are proprietary, but they are cloud native and they're cheap. That's the important thing, right? So GPT-4o Mini is the SLM from OpenAI. And O1 Mini, they are reasoning model, smaller version. So O3 Mini is there, and there is a new one. I think if you are using ChatGPT Plus, you will get access to that. O3 Mini High. They say it's better for coding, right? So the point is, in the enterprise ecosystem, if there are anybody looking to deploy SLMs or want to decide whether LLMs or SLMs, when to go with. So the basic rule of thumb is, if you want to have more privacy and governance, if you want to comply with privacy and governance, and also easy to fine-tune, easy to customize, go with SLMs. Open versions are there for you if you want to go with your own infra, and if you want to have a more control over your application or development, right? If you don't want that, and also the privacy. If you are really fussy on privacy, the better option is go for an open model, open SLM, and deploy it in your own infra, on-prem or your own VM, right? If you are not fuzzy on that, if the cost is your problem, better to go with cloud native but SLMs. Now, we were able to reduce, I can't exactly figure out the context, but when we were doing some pricing and capacity planning, we saw if we use GPT-4o, it's about $22 per unit, let's say. When we go for 4o Mini, it's going to be reduced to $7 or $8, right? There's a huge advantage there in terms of cost, right? But again, you can't assure the privacy aspect there. Still, your data is going there. So depending on your context, client's requirement, you can decide. Okay, so the important thing here, okay, I have about 10 minutes, right? 10, 15, fine. So I will show you 3 demos, right? Just to showcase the capability. Now, I highlighted the privacy and governance aspect. I highlighted the infra requirement aspect of SLMs, but most of the time people still have the problem, can these SLMs do a better job, right? It's fine, but can they do a better job? Do they provide accurate results as LLMs? So I tried few examples. So assume this scenario, right? I want to develop an application for an ambulance service. Now this is a very common thing in the US, not much in Sri Lanka. So the ambulance goes to the patient, take the patient and coming back. So they need to fill something called patient information when the patient arrives at the hospital. So the healthcare tech companies are looking to develop a solution when the ambulance is coming back, EMT personnel, can they talk to maybe a voice application and start giving patients information? Okay, John is coming, he's having these symptoms like that, right? So we can convert voice to text, and we can develop a solution using GenAI. When the patient arrives at the hospital, that particular DB is updated from the patient's info. You don't really need to do it at the hospital before putting the patient to the ward, right? Simulate that example, right? Then assume I have this context information. Now, I don't need to explain what is context information, right? Sanjit did a really good job, right? So I have this context information. It is explaining something related to John Matthews. He's a patient, 52 years old, address is there, he's having certain symptoms, blah, blah, blah. This information is there. Now, assume this is the output of that voice input from the EMT person. Now, I am trying to ideate a use case. I don't have the entire pipeline. I will showcase the Gen AI part here, right? Now, from this description, from this context information, I want to extract patient name, age, address, and the current symptoms. Those are enough for that form that I want to fill in the DB, right? So assume I give a prompt like this to a SLM, right? My instruction is there, you are an experienced healthcare worker. Can you remember Sanjit Stoll role playing? That's there, right? I'm giving a clear instruction. Your task is to understand the patient's context information and extract these things. Name, age, address, so and so, right? And I give the context information. Okay, so this is the one. So I will simply put it to SLM. So I'm using Pi4 here. I will showcase it in a bit. So you also can try this out. There is a platform called LLMs. There are a lot of SLMs, even LLMs, you can try it out, open source one. I'm using one, LLMs, right? I'm using the Pi4 model from Microsoft, right? That's Pi4. In the drop-down, there are a lot of models you can use, right? So I reduce the temperature to 0. I don't want surprising creativeness from the model. Okay, I'll give the prompt. Okay, it's also adhering to ethical AI, responsible AI. Yeah? As a language model, I must emphasize I cannot provide medical advice or diagnosis. It's improved. Previously, it was straight away, but that's not the important thing. You can see it's nicely extracting the entities, right? Age, name, address, current symptoms. It's clearly picking everything, right? You can do the same thing with GPT-4o, no problem, but you are spending on tokens and getting the same thing. Just like my very initial example, going to the supermarket with your racing car versus your Alto. You can get the job done here, and you are doing it with a SLM. You can deploy it in your own controlled environment. Privacy and governance is assured, at least to a certain level, right? Then you don't need to worry about the accuracy, right? So that is the capability of SLMs. So let me see the other one as well. Here the example is, assume you want to develop a chatbot for a bank, right? And you have a customer query coming to a chatbot. The customer is asking, I can deposit $2,000 every month. I need a higher return. I also need to be able to do transactions using checks. Suggest me the best saving account. It's a typical example, right? This can be a simple query coming to a chatbot in a bank, right? So assume you have a set of documents with your FAQs regarding information about all the accounts you have within the bank, right? So that information is there, right, in the context information. So this can, if you are working with Gen AI, you know RAG, right? This can be a part of a RAG application, RAG pipeline, right? You can get the context information from the VectorDB, and you can put the customer or the user query there. You can compile the final prompt and send it to the language model side. So here also, you can see SLM itself is understanding the context information and giving the best option, best savings account, right? We'll try to see, can quickly jump. So here also I'm using Pi4, right? This LMC's platform is a very, very good platform to try out and practice even prompt engineering. You can see it's giving the correct answer, money market account, right? With a very nice explanation, right? So if you don't need these explanations, you can do a prompt tuning and you can control your output. It's simple as that. All right. Then another one, the last one, bear with me. So the last one, that is for let's say you have a CRM. You have a CRM in your ecosystem. You want to develop a feature to send automatic emails to your customers, something like that, right? So I have a prompt for a use case like that, right? You are an experienced customer service agent. Your task is to write a polite and concise response in a single paragraph to a customer using the given context below. Likewise, again, a similar context is given. So here what I wanted to show is you can give the context even as key value pairs, right? Like the customer name, account number, like key value pairs. You can give separate instructions if you want, right? Your context information can be more varied. Still, SLMs can do the job you want, right? So this is the sample email written by the SLM, Pi4, right? So in that example, I clearly said, don't say something like, we will look into that. That instruction is correctly taken. And it is clearly explaining the reason for this connection issue. Likewise, right, you get my idea, right? There are a lot of use cases that you can use SLMs in an effective manner for a lot of enterprise scenarios, right? Okay. So the last parts, the key takeaways. So I'm not saying LLMs are bad. So once I did this kind of a talk, someone came to me and asked, are you saying LLMs are bad? No. That's not the case. LLMs can be there. They can do a really good job, right? So we are thinking of a coexistence. In your enterprise ecosystem, both LLMs and SLMs coexist, right? So as users, we should be able to select the best option based on your use case, based on your privacy and governance requirement, based on your cost KPIs, and based on your engineering requirements, like whether you want to fine-tune, whether you want to deploy it in your own VPC, likewise. So there are certain factors that you can decide. Both these solutions, these approaches, these SLMs and LLMs, both things are there on the table. It's up to us to select the best one based on your requirements, right? Especially cost, privacy, infra is a challenge for you, or it's in native in your use case, SLMs are better. But if you want to go for a broader context, if you want to support multi-languages, if you want to do a multitude of tasks, in that case, and you can compromise privacy and cost also, LLMs are going to be the best option. All right, thank you all. So that is my attempt to give you something on SLM. I hope you at least got something. If you have any Q&As, we can.
Thank you very much, Dr. Lahiru Ariyasinghe, for your enlightening session for small language model, the compact future of AI. So audience, I think you have learned something about small language model. So now the questions and answer session. Over to you for if there are any questions you can raise.
Thanks, Dr. Lahiru, for your wonderful session. So just a question. So you mentioned about different types of SLMs. Can an SLM talks to a LLM? Can it be configured like that?
A hybrid approach. I mean, yeah. So you can develop a use case where in your operational flow, LLM is doing a one part and SLM is doing another part. I mean, if you want to ideate, let's say you want to work with Sinhala language on a use case where, let's say, for customer service. So in that case, maybe you can use the support of LLM for the transcribing part, or maybe understanding the Sinhala knowledge part, maybe doing a conversion to English or something. Then you can use the SLM in the flow to do maybe a sentiment or something. But again, that decision criteria should be decided very precisely and cautiously, because you introduce a LLM, you introduce a SLM, maybe multiple ones, the cost is there, complexity is there, privacy concerns are there, so we'll have to balance. But again, technically it's possible. We have done use cases as well, but it should be very use case dependent. Because most of the use cases, even the Sinhala language thing, I can't remember the exact thing, but yesterday actually, I created a sample transcript between a conversation of a customer and a call center agent in Sinhala, and English words as well. That's a normal thing, no? Then I gave it to Pi4. The conversation is about customer is complaining on the bill issue and something, and I basically asked to classify the customer's sentiment. It did really good job. Even Gemma 2 actually understood the Sinhala terms. ඕගොල්ලන්ගේ package එක වැඩක් නැහැ. बाकी Sinhala terms, it understood very well. So again, there's a very now fine line. But technically, yes, for use cases, we can have both working together.
Okay, because what I'm aiming at is like, for example, if a customer asks, let's say if it's a banking chatbot or something like that, where a certain amount of private information needs to be shared with the bank to give the credentials saying that this is a particular customer. And then the question might be more generic, subject-specific matter. So let's say you train your, I don't know, it's just a hypothetical thing. You train your SLM where you filter out the private parts. Yeah. And then you use a LLM to get the more generic answer to the technical question that he or she might have, and then give it back to the customer. So that's what I'm trying to aim at.
Some sort of, architectures are possible like that. Yeah.
Thank you.
One more question from the undergraduate here. Hi, sir. As a third-year undergraduate interested in data learning and the machine learning, what key skills or experiences would you recommend to stand out as a valuable data analysis in today's industry?
So someone from the audience?
Someone from the audience.
Okay, sure. So one thing is be brilliant on basics, right? Gen AI is there, you can call an API and do the thing with prompt engineering. But if you really want to understand the underlying thing, you have to be brilliant on deep learning. Of course, machine learning, especially on neural networks, theoretical aspect. Be brilliant on that. And then I think you are thinking about data career. In that case, go out of Python, not only Python, try to learn some other languages as well. Because of this foundation model thing, software engineering community, data science community are kind of overlapping these days, right? SE teams trying to work with LLMs because it's an API integration. So you will have to work beyond Python, beyond just statistics. Maybe work on other languages, be brilliant on basics. And the other important thing, everybody else needs to be really good on prompting, right? I was listening to someone called Matt Welsh from, now he's in a startup, but he was previously in Google. He was saying in his talk, the final slide, the next programming language is English because of prompting. So I would say it's not only English, it can be any natural language for us. So like keep the bigger picture. And the other one is the training that we did for last 3 years, collecting data, doing data cleaning, maybe doing a EDA, right? Training a SVM, some kind of a thing, maybe training a CNN, right? It may not be there in the future. There are foundation models, you take them, you do a fine tuning, and you are good to go. You don't need to train from scratch. So will we ever train again? That is something for the future as data scientists. But again, be brilliant on basics. You can't understand what is coming without knowing the basics. Okay.
Dr. Lahiru, I have one question for you. This is two questions actually. This is to do with IP rights. Now, if you are using a LLM or small language model, and you put your use case, your requirements, and then you ask you to generate the code for you. So I think the code now sits in the behind the scene also, right, in the model you use, right? And the IP rights of this code that is generated, which are you going to use in your product, which you're going to claim that it is my IP. Is there a discussion around that? Right?
Yeah. That's a really good question. So if you are working on an intellectual product and you generate a code using a language model, large or small language model, what is the IP of that? But again, that is something in discussion, and there are a lot of debates, there are different views, right? The same sort of an analogy is, now J.K. Rowling, Harry Potter author, right? What if we fine-tune a SLM from all the Harry Potter books? And now all of a sudden, it can generate something like Harry Potter. Now, is there a IP violation or not? That is a big debate. So, that is something we'll have to discuss separately. But in my point of view, it's going to be 50-50. You are the one prompting, you are the one doing the prompt engineering part. You still need to give the, all the BRD and everything, right? Although we saw it in the last talk like that, code will be there, but still you will have to do the tweaks, right? It's not going to be 100% LLMs code. At least right now, you'll have to do your own tweaking, customizations, feature adding, and so on. So then still that question you asked, still in a debate and more towards the developer side. But when the models are growing very smart, you really don't need to look into the code at all. You put it to production. In that times, there will be a debate on that.
The second question is the code that we produce using LLM, right?
Yeah.
The quality of the code.
Yeah.
Are there AI tools? Now use SonarQube, right now, right? In our organizations, they measure the code quality. The code produced by these models, the quality of it. Are there tools to measure that? AI tools to measure that?
I think something generated from a model, again using an AI tool to grade it, may not be the ideal thing. But there are certain things that we do in prompt engineering security as well. We use a one LLM to check the output of another one, something like that. But still, there are challenges in the code generation. You can't really put the code into production. Of course, like common things, frequently used things like loggings, profile picture upload, those things, fine. But when it comes to a customized thing, we still need to look into that. The code will have to tweak. So that is where we need to have the balance of using Gen AI for code generation and actually be doing it. Right? We'll have a balance at least right now. Because not the entire code developed by the Gen AI, it's not always accurate. Right. So if your development team is putting more time to correct the code developed by the LLM, it's not effective. Yeah. So right? Then you are wasting man days, basically man hours.
For the
right?
code quality, in that case, we still have to use something like Sonar, right?
Yeah, it's still, I think it is with human right. Reviewers. Okay. Yeah.
Thank you.
Okay, thank you very much. I think very interesting session. You have a lot of questions. Yeah, you have any further questions related to small language models, please scan the QR and raise it. So we will ask from Dr. later to answer all those questions. Yeah, so Dr. Lahiru, as a gesture of our appreciation, we would now like to present you with the token of gratitude. Madhura, please come forward too. Once again, thank you, Dr. Lahiru, for being with us and sharing your valuable. Thank you very much. So I think now you all are waiting for our next session. What is the next session? Okay, we have the tea and coffee session now, so we have 20 minutes. So please go and enjoy.